Hello. So in this video, we are going to be talking about domains of piecewise functions. So the domain of piecewise functions, they're always given explicitly. And this can be sort of a little misleading at times. In particular, there's not really a notion of natural domain because the domain must always be given. So remember, the whole idea here is that piecewise functions are basically taking a bunch of different functions and gluing them together at certain spots. But to know where you glue them together, you have to explicitly give those domains. Nonetheless, there are some key observations we want to make about the domain, some sort of common sort of situations you can see so that we pick them out as we go, okay? So consider this particular example here. And again, just as a quick 2-second refresher here, we have the particular function and the domain that function is on, right? So we have three functions here, 1/2 x squared between 0 and 2, 2 between 2 and 4, and square root of 3x minus 8 when x is bigger than 4, okay? Now, again, we're focusing on the domain part here. So the first thing I want to point out is actually about these 2's right here. So in particular, if you look at the top one, we have that x is strictly less than 2, right? And then in the middle one, we have that x is greater than or equal to 2. And this is actually sort of an important note here, is that the actual value of 2 only shows up in one spot, right? So this is important because we want it to be a function. And if we have the value showing up with more than one spot, then we run the risk of having more than one y value because we'd have to evaluate it at both this top value and, right, the top function and the second function if 2 is in both of them. And if those are different values, then it's no longer a function. That's bad. So the actual value of 2, the sort of good practice here, is that if we have a value of 2, or whatever this sort of point is here that we're transitioning from one to the other, that we only include that in one of the two. And a lot of times it's important which one of those two it's in. Like that's part of the gluing together process. But it's important that it's not in both, right? That we don't have x less than or equal to 2 and 2 less than or equal to x, okay? So at the values 2 and 4, our function type changes. At 2, we only include it in one spot. But when we look at the 4, right, we have x less than 4 and then 4 less than x. But that means that at the value 4 itself, the value of 4 itself isn't actually included, right? It's not in either place. I don't have the or equals in either spot. So that means that unlike 2, where 2 is actually, as a domain value, is included here in the middle, 4 doesn't actually have a spot. It's not actually included, right? So that means if we want to look at our domain of the overall function, right, the domain of p of x itself, right, our overall function, that domain spans all of the subdomains, meaning that it's across the entire set of the provided x values. So in this case, it's going to be all x, right, such that we have x less than or equal, greater than or equal to 0, less than 2, but then it also includes 2, right? So we actually are including 2, up to 4, strictly less than 4, and then anything strictly bigger than 4. So putting that together, it's really everything greater than or equal to 0, including 2, because 2 is up here, except for 4, right? So I have 0 up to 4, but not 4 because of the lack of or equals 2 on that, and then everything bigger. So if we write this domain out in the sort of interval form, we would have this as 0 to 4, where I'm including 0 but not 4, and then 4 to infinity, again, not including 4, okay? All right. As a last note, these values that we see, they're depending on professors, settings, and various other things. Sometimes you'll see these things called pivot points or transition points. So just putting that on your radar as a vocab thing. Sometimes you'll see, right, where we're going from one line to another, like this 2 here or this 4 here. Sometimes you'll hear those called transition points or pivot points. All right. So what we do, we talked about the domain of the piecewise functions, right? In particular, they are always explicitly given. They're never natural domains because we have to know exactly where we're gluing these things together. But along with that are this sort of caveat where if we're doing a transition, right, if we have like less than 5 and greater than 5, we can only include that value, that domain value, in one of those two spots, right? That's the sort of conventional way of doing it. And we may not include it at all, in which case that value is just not in the domain, right? So it should be at most included in one of those, but it may not be included in either line, okay? So that is that.